number versus a rational equation. So what's a rational number? No. Look at the root of the word. Ratio. So fraction. So a rational number or a fraction number would just be a number that's a fraction. So it's a number that's a fraction. So what would then be a rational expression? A rational expression. What's an expression? What are we using when we have an expression? Oh yeah, you need one of these. Okay, so when it's a expression, Spencer, it means that we have variables. So 2x minus 3 over 5 would be a rational expression. So it's a fraction with variables. Yeah, because it's rational expression. So fraction with variables. So the similarities, they're both fractions. The difference is one has a variable, one does not. So number 2, or we're going to skip down to number 2. In the expression x squared minus 9 over x minus 3, explain why x can't equal 3. Why can't? So you can't divide by 0. Just can't. It's just not possible. You will implode. Okay. So let's try number 4. Identify the non-permissible values. So all the ones we don't try, you can try on your own later. I'll put the key on the website. Okay. So the non-permissible values. What are the non-permissible values here? X can't equal to 2. Now, there's no variable with the 3, so it's not a it wouldn't be. If it was 3x, then you'd have 0. Okay? And we just look at the denominator. Where is there a variable in the denominator? So not the numerator. Okay. So this guy, in order to see his MPVs on the bottom, what do we have to do with him? Factor. I like that. Hey, what can we factor out? 2x. So 2x squared divided by 2x, what's left over? An x minus 5. Yeah, we took an x out. Okay, so what's my MPVs here? X can't be equal to 0 and 5. Okay, try the next guy. Remember, before you can find MPVs, we have to factor. Okay, how can we factor this guy? What is he? X squared minus 4. Difference of squares. So what does he become? X plus 2 times x minus 2. So my MPVs are that x can't be equal to plus or minus 2. Okay, so simplifying. Let's look at B, 5B. In order to simplify, what's our first step? Factor. It seems to be a theme always. Always we want to factor first. Okay, no matter what we're doing in a rational expression, we factor if possible. What can we factor out of the bottom? So first 6 and 12, what could you factor out? Well, 6, okay? We look at we have an a squared and a. We're going to take the largest power in common. So a squared and a, what could you pull out? An a and a b and a b squared? B. Okay, so we're going to be left with 6a squared divided b divided by 6ab. What's the only thing that's left? you had 6a squared b divided by 6ab. Just an a. Right, these guys gone, just one a. Okay, and then what's 12 divided by negative 6, or negative 12 divided by 6? Minus 2. And then ab squared divided by ab, what's left over? 1b. So what can reduce out here? 3ab and 6ab. So let's do the ab's first. ab and ab. 3 and 6, what can we reduce that to? 1 over 2. So now we have 1 over 2 times a minus 2b. Now, NPVs. Where do we look when we want to do NPVs? Come on, participate, Stacey. Do that later, okay? But please do that later. Right? Put this away for now. You'll have time in class, okay? Later on today. So before cancellation. So we have a few. A can't be equal to 0. B can't be equal to 0. And then A can't be equal to 2B is another one. So how I get that is when, if you set A minus 2B to 0, solve for one of the variables. So A can't be equal to 2B. Let's look at D. Okay, so first step, factor. Do you want to try and factor this guy? Start with factor top and bottom. What can you factor to the top? So 5 minus 5x, what can we pull out? A 5. 5 divided by 5, what's left over? 1 minus x. So whenever we factor something out, you still have a 1 left over, right? Anything divided by itself is 1. Okay, what's on the bottom? Difference is squared. So x squared minus 1, we square root both. Square root x is x square root of x squared is x, square root of 1 is 1, 1 plus 1 minus. Now, are these the same right now? The 1 minus x, is that the same thing as x minus 1? No. How can we make them the same? Take out a negative. So if I factor out a negative in the first, the sign switch. We get a positive x and a minus 1. We can rewrite that. So factor out a negative. And then, will something cancel? Now it will. Negative 5 over x plus 1. And then we still have to state NPVs. X can equal 2 plus or minus 1. Always go back to before cancellation. Okay, so multiplying. Let's go to 6b. Actually, yeah, let's look at 6b. Okay, when you multiply, you're welcome to multiply straight across, then reduce, or you can reduce and then multiply straight across. Either's fine. Is there any problems here? You see with this guy. Cut letters, that's a problem. Okay. Start. Can some things cancel out? Yeah, some things can. if you want, we can go straight across and multiply right now. What's close to canceling out but not canceling out? 3 minus x and x minus 3. How can we make these the same? Take out a negative. Let's do it out of this guy. So x times x minus 3 all over 5x squared times 25x over negative x cubed. And now we can write this as x minus 3. Okay, so let's do some cancellation. What can we cancel? X minus 3. Now, do you want to multiply straight across and then reduce? And the 5? Yep. So we can divide both of these by 5. So if we want to go straight across now, I have an x times a 5x. What would that give me? 5x squared. And we have an x squared times a negative x cubed, which is negative x to the 5th. Okay, can we still reduce? Yeah, what can we reduce? The x squareds, right? So we can subtract, so this will be 5 over negative x cubed. Take away an x squared from both. And NPVs, x can't be equal to 0 and 3. You all should be able to get the NPV question on your diploma correct. I'm guessing there might be one. I'm hoping so, because that's like a good question you should all get, for sure. Okay, why don't you try C? So can you at least start and try and factor this as much as you possibly can? Okay, do you want me to work this one with you?
No.
You can do it. It's not that ridiculous. Okay, so factor. So looking at the top, right away, what should you notice about the top? Difference of squares. So what does he become? Two terms separated by minus, we can square root both. So the first guy, y minus 3, y plus 3. Okay, on the bottom, what could you factor out of those two? 2y. Okay, so 4y squared divided by 2y is 2y, and 10y divided by 2y is just 5. Times, what can we factor out of 2y cubed minus 5y squared? Y squared is in common. 2y minus 5 okay, Sawyer, what can I factor out of 3y squared minus 3y? 3y.
Yes, sir.
Good job. Okay, 3y squared divided by 3y is y. Anything divided by itself, what's going to be left over? 1. Okay, is there anything that cancels? 2y minus 5. Okay. Yay. Okay, that's all for now. We also have 1y squared on the bottom and 2y's here. Will that cancel out the y squared?
Yes.
Yeah. So we can go straight to canceling these guys out if you like. Because a y times a y is a y squared, so those will cancel out. So we're left with, on the numerator, y minus 3 times y plus 3. And then 2 times 3 is 6 times y minus 1. Y can't be what? Careful, there's a number in front. So it'd be 5 over 2, 0, 0 again, and 1. Fun? Coming back to us? A little bit better than yesterday, maybe? Slowly? Okay, let's go to 7, number B.
Number B.
Number B. Yes, sorry. It's already in factored form. Yay. So what do we do when we have division? Multiply by the reciprocal. Okay. Reciprocal. Yay. Just so you know, a week from today is your replacement exam.
Thank you.
So it's coming.
Almost any marks.
No?
I have too low marks. If marks are too low in this place, well, like they're too high.
Aw. Okay. So what can we cancel? Is there anything we can cancel out? What? What can we cancel? Jody? Is there anything that can reduce out? Is 3x plus 1 the same as 1 plus 3x? Yeah, totally is. Right? They're both 3x plus 3x plus 1 plus 1. They're the same thing. They're just written in a different order. Subtractions you have to be careful of, but the addition, they're the same thing. That cancels. Okay, so on the numerator, if I have a 5x times an x, what will that give me? 5x squared times x plus 1 over 2x to the 4, x minus 1. Anything else can cancel? X squared. We can divide top and bottom by an x squared. Right? So this is going to become a 2. So our final answer is 5x plus 1 all over 2x squared x minus 1. MPVs. Go. Now, where do you have to look for MPVs? Yes, Andrew. Do you want to tell me them? Sure. Yeah.
Wow. Thank you.
Oh, wait. Yes, we can.
Sorry for the off-topic.
Yes. No, only if this is a negative x. That could only work if this was 1 minus x, right? If the x was negative here. Because if you factor out a negative, it becomes negative x minus 1 in this case. Okay, so folks, when we're looking at MPVs for division, we have 3 places to look. So this is what they'll do on a diploma question is they'll probably give you a division question if they're asking for MPVs. Like if a question about MPVs, it'll probably be division because then you also have to remember you have to do both the top and bottom here. Okay, so our MPVs, because it's on the denominator here, we flip it, and now it's on that numerator became the denominator. So x can't be equal to 0, 1. What's this going to be? It's going to be a negative 1/3. Good. And this guy here, negative 1. Now this guy, I know some of you are shaking your head at me. When you solve this for 0, we subtract 1 and then divide by the 3. Because it's written backwards right now, and that second over first only works if the x is in front. So if it was written as 3x plus 1, it's easier to see negative 1/3. Yeah? Yeah. Okay. Do you want to try one? No. Okay, do you feel good about division, or do you feel, yeah, it's very similar. Okay, let's move on. Let's go on to the next page and start with subtraction, because this is where it gets tougher. Oh, yeah, for sure. Okay, if we have the same denominator, what are we going to do? Can we go straight to adding and subtracting? Yes. 4x plus 10 all over 2x plus 5. We can just add the numerators and write it over the same denominator. Now, is there something we can do with the top? What can we do with the top? Take out a 2. Oops, I forgot a 2 there. What happens? They cancel out. The answer is 2. They're still in the NPVs. X can't be negative 5 over 2. Okay. So it's easy if it's already a common denominator. If it's not a common denominator, we have to figure out the common denominator. So what would be the lowest common denominator here of 8 and 6? First of the numbers, 8 and 6. No, we're looking at we have to look at the lowest common multiple, basically. So not factor. 18, no, 16, 6 doesn't go in 16. 24, okay, 24. Yeah, and we also have a y in the denominator, so that's going to be part of the lowest common denominator. So you have to include all variables. Okay, so to make this 8 into a 24y, what do we have to multiply top and bottom by? 3y. Okay, minus, to make this 6y into a 24y, what would we have to multiply top and bottom by? 6 times 4 is 24. Okay, so now do we have a common denominator? Yeah, 3y times 3y. 9y squared all over 24y minus 5 times 4, 20 over 24y. Now that they have the same denominator, can I write them all over 24y? Yeah. 9y squared minus 20. It's not a difference of square because 20 is not a perfect square, so we're done. Okay. So 12. What would be the lowest common denominator of this guy? 7 times x minus 5 times x plus 2. We have to include all monomials and binomials that are on the denominator. Right? So these are attached. They go together, that x minus 5. Okay, so who's missing out of the first guy? The 7 and the x plus 2. So we're going to multiply top and bottom by 7 and x plus 2. Yes. Yeah, and they have scrap paper and stuff too to write on. And they really space out their questions. Like, there's only 40 questions, but it's spaced out. Okay, 3x over 7 times x plus 2. What is he missing? The x minus 5. So top and bottom by x minus 5. So now you can see they have the same denominators. So we're going to write it all over the same denominator now. We can go straight to simplifying if you want. Or not. I don't know. Okay, I do, but I don't know what you want to do. So negative 4 times 7, what's that equal? Negative 28. So negative 28 times x, negative 28x. Negative 28 times 2, negative 56. Okay, then 3x times x, 3x squared, and 3x times negative 5, negative 15x. So last, we just have to collect like terms. Okay, 3x squared, negative 15 minus 28. Help me. 43. Negative 43x minus 56. And don't forget to state NPVs. So NPVs, what are they? 5 and negative 2. Okay. One more. Do you feel like we should do a subtraction? again, or move on? Yes, one more? Okay, we're doing 13. Okay, first step before, this is a good question because before we can get a common denominator, what do we have to do? Which is already done for us before. Factor. So what can you factor out of x squared plus 7x? X minus, okay, what can we do with 49 minus x squared? What is it? Difference of squares. So what does it become? 7 minus x and 7 plus x. Okay, lowest common denominator, what is it going to be? That's a good question. Okay, first of all, are there any repeats from here to here? X plus 7 is the same as 7 plus x. We need to include everybody. So we have to include the x plus 7, which is accounted for now. You don't have to count for it twice. And then the 7 minus x. No, you just don't have to count it twice. So if it's already there, I'm not going to multiply top and bottom by it again. So, for example, what's missing from this guy that this guy has? Or what our LCD has? Are the 7 minus x. So we're going to multiply top and bottom by 7 minus x. And if you want, you can go straight to writing it all over a common denominator. This guy, what is he missing? Just the x. Instead of writing this all out, let's go straight to that. Okay, so on the numerator we can simplify this. We have 7 minus x minus 2x. What can that simplify to? 7 minus 3x. Are we done? Non-permissible values. X can't be 0 plus or minus 7 and 0. Okay, we're going to go on to 14. I'm going to show you one of the methods we learned when we, Okay, so when you have a fraction equals a fraction, what could we do with this to solve it? Cross multiply. So we could write it as 6 times x plus 1 equals 4 times 2x minus 1. It's probably the easiest way, as long as we have a fraction equal a fraction. And then expand and solve. So expand, I mean distributive law. 6x plus 6 equals 8x minus 4. And how do you solve? Now, if it's just one x, not an x squared, it's an x. So bring all the x's together. So let's subtract 6x. So I have 6 equals 2x minus 4 then. Add the 4, bring all the numbers together. 10 equals 2x. So and divide that by 2. Okay, so 5 is equal to x. Now, we're actually not done, because what do we have to state? Which you should probably state in the beginning. Non-permissible values. So what are they? 1 over 2 and negative 1. So is our solution okay? Yeah. If not, we call it extraneous. Okay. So we looked at a couple ways yesterday to solve this. One is we can add these, get a common denominator, then cross multiply. Another way that we learned was we multiply everybody by our lowest common denominator. And this is what we did in class a lot. So what's the lowest common denominator of this guy? X times x minus 4. Okay, that would be the lowest common denominator. So we're going to multiply each term by the lowest common denominator. So this might look familiar. X times x minus 4 times 1 over x minus 4. Oh, hello. There you go. Oh, there we go. Plus x. This is not the only way to solve. You could get a common denominator and add. Equals. I'm just going to show you one of the methods we learned in class. Okay. So what happens here? The x minus 4's cancel. What happens here? The x's. This is a way we use to get rid of the fraction. So now we have just 1 times x, or x, plus x minus 4 times 1 is just x minus 4, equals 2x times x minus 4. Easy peasy now, right? I don't know, maybe. Because it's a lot simpler. There's no more fraction. So on this side, we have 2x minus 4 equals 2x squared minus 8x. How do we solve a problem with a square in it? We're going to factor. So in order to factor, we need to bring everything to one side. So we have to bring everything to the x squared side. So 2x squared, I'm going to subtract 2x. This gives us a negative 10x. We subtract it from the 8. And then add the 4 over. Is there anything we can factor out of this? 2 minus 5x plus 2. Okay, so the question is this factorable? Are there two numbers that multiply to 2 and add to negative 5? No. So what do you have to use to solve this then? Quadratic formula. Yeah, and okay, so either quadratic formula or you can use a graphical method. I'll show you both. You should know how to do both. So quadratic formula is on your formula sheet. Negative b plus or minus square minus 4ac over 2a, hey, over 2a, hey. Yeah. Okay, that was a good time. Those were good days. Simpler times. Those were simpler times. They were, though. Okay, what's my a value here? 1. So the a would be 1, b would be negative 5, and c would be 2. So it becomes negative 5. What will that be? Plus 5. So 5 plus or minus the square root, negative 5 squared minus 4 times 1 times 2. Yeah, you can. You can. It says here answers an exact value, so we can leave it as a square root. Obviously, my MPVs are 0 and 4. I'm probably not going to get 0 and 4 with this, right? Because it wasn't factorable, you're going to get a decimal. So 5 squared is 25, minus 8 is 13. Yeah? No, 17. Thank you. So 5 plus or minus root 17, you type that in, you get 17 over 2. So let's punch this in. Remember, if you type this into your calculator, oh, I should get mine open. You'd have to put brackets, so 5 minus root 17 around your numerator. You might have to use quadratic formula, honestly, on a diploma. You might have to. So make sure you study it. Okay, so that's one answer, and then we just need to go back and make this one a plus. So there's our two answers. What's the other way I could solve this? 0.44 and 4.6. So what else could you do if it's not factorable? Graph it. Okay, so go to y equals. You can type in 2 times, even if you want, x squared minus 5x plus 2. And we want when this equation equals 0. So what part of the graph are we actually looking for? The intersection with the x-axis, our zeros, which is second trace number 2. We can go left side, right side, people today, and guess. Okay, so that gives you 1, 0.44, and then you get the other 0. Left side, right side, guess. If it is factorable, it's a lot easier to get the solution though. So most likely it will be factorable, and most likely it'll be a simple trinomial, not a complex trinomial, okay, or a difference of squares. Yeah, you really could, because it is going to be, unless they ask you a question where it is factorable and they say a numerical response, x minus a times x plus b, what's the value of a and b in numerical response? Then you'd have to factor, as long as it's factorable, right? Yeah. So they have their ways. They're sneaky. Okay, yeah. I should go through one more of these, hey? Solving? Yeah, let's do this guy. Okay, first step, we're going to factor everything before we do anything. That's always our first step. So what can we factor in this beautiful picture? No, there's stuff we can factor. Okay, n squared minus 4 is a difference of squares. What else? We can factor 3 out of 3n plus 6. Okay, so let's factor. Sorry that I didn't give you much room. I apologize. N squared minus 4, what will it become? N minus 2 and n plus 2. And then we factor out the 3, we get n plus 2. Okay, lowest common denominator, what is it going to be? Pardon me? And you need an n plus 2 and n minus 2, and a 3. Okay, so I'm going to use this method that we did in class here above. We're going to multiply everybody by the lowest common denominator. So the first guy, we're going to multiply by 3n minus 1 times n plus 2. It's good, right? It gets rid of the fraction. I'm also missing something else. This should be minus 2, right? Thank you. There you go. Minus 2 plus 2. The only thing about this method is it's this step right here, pretty lengthy. A lot of writing here. But it makes everything a lot prettier in the end. And my most favorite part is the canceling part. I don't know about you, I love when things cancel. It feels so good every time you take something away. No? No? Gone. Like an easy. Okay, so first guy, what cancels? N minus 2. This guy. N minus 2, n plus 2. And this guy, 3 and n plus 2. So you could also go straight to this next step if you can figure it out, right? This n, we're going to multiply by what he's missing. He's missing the 3 and an n plus 2 from the denominators. But so times 3 times n plus 2 is left over here. Or you can write it as 3 times n plus 2 times n if you like. Doesn't matter. Plus 3 times the 1 is just 3. Equals, on this side, all we have left over is n minus 2 and 3n minus 1. I might actually write that as a 3n. It's kind of ugly with the 3 on one side and the n on the other. So bringing in the 3n, right? Do you know what it is? You got it? No? Yeah? 3n? Brad? So 3n times n, 3n squared, 3n times 2, 6n. This is actually 3n. I'm going to put the n in front instead. Because it's ugly in the back. Plus 3 equals, now we got to FOIL this out. So beautiful. N times 3n, 3n squared. And then n times negative 1, negative n, negative 2 times 3n, negative 6n, negative 2 times negative 1, plus 2. So what's going to cancel out here? The 3n squareds, right? If I subtract 3n squared to their side, they're just going to cancel each other out. They're both on both sides. If I subtract 3n squared, they're gone. They cancel each other out. That's a really nice thing, because then solving this puppy is a lot easier. We have 6n plus 3 equals negative 7n plus 2. So let's bring all the n's to one side, all the numbers to one side. So adding 7 is 13. Yes. And then subtracting the 3 is negative. Yeah, we're going to add it to the other side. So I'm skipping a step, sorry. So it's a negative 7, right? So I added 7n to over here to bring it over. And then subtract 3 to bring this guy over here. And divide by 13. Is that a non-permissible value? No, it's fine. Okay, so the last thing we're going to do is look at a word problem, because these were probably the toughest in this unit. Number 17. Which is actually 18? No, it's 17?
The little flat?
Oh, there it is. Okay, so on your diploma, they're going to either ask you one of two things. If it's a word problem, they can't ask you to write the equation and solve. So they give you a word problem. They might just ask you to write the equation. So the multiple choices would be which of these are the right equation to set up this rational expression to solve it. Or they'll give you a word problem with the equation, and then you just have to solve it. Okay, it won't ever be both. So these problems in rational expressions, we're always using that distance equals rate times time formula. Right? Or speed is distance divided by time. That's essentially the formula we're using. So we have 3 different variables, d, r, and t. Okay? And setting up a box is helpful. Maybe don't make it too big, else you won't have room to solve like I just did. Awesome. So we have one particular leg of the race spans 200 kilometers. One team covered this span, so it's a dog race, I believe, right? It's a dog race, yeah. So one team covered this span at a rate of 10 kilometers faster on the way there than on the way back. So right away we know the two situations. On the way there and then on the way back. If the total time for the trip was 9 hours, what was the team's average speed on the way back? So let's fill in what we know. What do we know about this trip so far? 200 kilometers on the way there and on the way back. Okay, now what else did they give us information about? Okay, it was a total of 9 hours. That's a total. So there and back added together is going to equal 9. That's a total of about 9 hours. So on the way back, they were 10 kilometers slower. Because one team covered this span at a rate of 10 kilometers faster on the way there. So on the way there, if this is our speed of x, then this would be x plus 10. It took 10 more. It's faster. Oh, it would be opposite. It would be x minus 10. X minus 10. Because it says this is your speed, right? So faster is a greater number. So it says one team covered the span at a rate of 10 kilometers faster on the way back it was faster. One team covered the span at a rate of 10 kilometers on the way there than on the way back. So on the way there was faster by 10. Good. So you could have x plus 10 here and x here, or x and then x minus 10. Okay, so we need a formula for time relating these two boxes together. So if distance equals rate times time, how do I get time by itself? Divided by your rate. So time is d over r. D over r. Which we expect it to be a rational equation because, well, we're studying rational equations. Okay, so we now, what equation do we have here? We know it's a total of 9 hours. 200 over x plus minus 10 equals 9. Yep. 9 hours, yeah, 9 hours. Okay, so what would be the lowest common denominator here? X times x minus 10. So if we're going to multiply each one of these by x times x minus 10. What are we left with here? What cancels? Let's say that. The x's. Okay, the x's are going to cancel here. X minus 10 will cancel here. We have 200 times x minus 10 plus 200 times x equals 9x times x minus 10. Okay, so let's expand this and then see what we have to do. So 200x, we're going to distribute, minus 2,000 plus 200x equals 9x squared minus 90x. Okay, so we have a problem. We're solving with an x squared. So what does that mean if we solve with an x squared? Put everything on one side. You might want to collect like terms here first. So we have 400x minus 2,000 equals 9x squared minus 90. And then bring these over. We're almost done. This is the last question for now. Okay, so I have 9x squared minus, oh, this was a plus, wasn't it? Plus 10? Or is it a minus 10? No, it's a minus 10. Okay, good. Good, yeah. Okay, kind of ugly. You might want to factor it, but you don't have to. We could also use quadratic formula, because I'm pretty sure 9 won't go into 20,000. Let's check. Yeah, and it won't go into 400, so 490. Yeah. Okay, so that you could either use graphically, or instead of doing a complex factoring, we could complex factoring, which is pretty ugly. We have to go two numbers and multiply first times last and add to the middle. So instead, it's easier to solve this either graphically, or, which you might have to zoom out to see and then do your zeros, or quadratic formula. So negative b plus or minus square root negative b squared minus 4 times a times c all over 2 times a. Now, is it possible to have a negative answer here? No, so we can go ahead and just type this all in. So 490 plus, I'm not going to have the minus version, square root negative 490 squared minus 4 times 9 times 2,000 Square root divided by 18. There's my answer. Then do it in steps. Like first figure out the inside, right? Do it in steps then. So it's going 50 kilometers per hour on the way. What do they want to find on the way there, on the way back? On the way there, so that's good. So 50 kilometers per hour. Okay. So yesterday we worked on rational expressions, and I gave you time for the practice exam. I'm going to give you some time to work now, because you need your own time to practice. So let me just stop this video for a second.